Hi guys, good morning again. Let us continue the session where we left. We were discussing about a lot of things on friction. In this session we are going to discuss about the effect of engine variables on the engine friction. Let us consider few variables which are affecting the frictions. The first one is the effect of stroke to bore ratio. Second one is effect of cylinder size and number of cylinders. Third one is effect of number of piston rings. Fourth one is effect of compression ratio. Fifth one is effect of engine speed. Sixth one is effect of oil viscosity. The sixth one is the effect of cooling water temperature. The last one is the effect of engine load. Let us consider one by one. In the effect of stroke to bore ratio, an engine friction and economy is very small. High stroke to bore ratio engines have equally good friction as that for low stroke to bore ratio engine. At high speeds, the higher stroke to bore ratio engine may leave some disadvantages. The second one is the effect of cylinder size and number of cylinders. The friction and economy improves as the smaller number of larger cylinders are used. This is because the proportion between the working piston area and its friction producing area, that is, circumference is reduced. Thus, there seems to be some justification for the layman's notion that 4 and 6 cylinder engines are more efficient than 8 cylinder engines. The third one is the effect of number of piston rings. The effect of number of piston ring is not very critical, and this number is usually chosen on the basis of the cost, size and other requirements rather than on the basis of their effect of friction. The effect of compression ratio depends. The friction mean effective pressure increases as the compression ratio is increased, but the mechanical efficiency either remains constant or improves as the compression ratio is increased. If the displacement is varied to keep the maximum engine torque constant, the result is better part load friction characteristics. Effect of engine speed depends. That is, engine friction increases rapidly as the speed increases. The best way to improve the mechanical efficiency at high speed is to increase the number of cylinders. The effect of oil viscosity. Higher the oil viscosity, greater the friction loss. The temperature of the oil in the crankcase significantly affects the friction losses, wear and service life of the engine. As the oil temperature increases, the viscosity decreases and the friction losses are reduced during the certain temperature range. If the temperature goes higher than at a certain value, the local oil film is destroyed, releasing in metal to metal contact. The effect of cooling water temperature is another thing we need to consider. The cooling water temperature effects. A rise in cooling water temperature reduces the engine friction through its effect on oil viscosity. During starting operation, the temperature of both the oil and the water is low, hence the viscosity is high. The result is high starting friction losses and rapid engine wear. Finally, the effect of engine load. As the load increases, the maximum pressure in the cylinder has a tendency to increase slightly, thus result in slightly higher friction values. However, this increase in the friction loss is more than compensated by the decrease in the oil viscosity due to higher temperature resulting from increased load. Further, in case of petrol engines, the throttling losses reduces at the throttle is opened more and more to supply more fuel for allowing an increase in engine load. Both these effects combine to reduce the frictional losses of the petrol engine as engine load is increased. However, the diesel engine, the frictional losses are more or less independent of the engine load.